Evening. My name is Denzel. I am the lead for blockchain in Chuka University, and I will be taking you through this session today. So today uh, we will be creating, going through Solidity, but we will be writing a smart contract so that we understand the language in depth. So, what you're going to do, you're going to search your Remix IDE. You're going to search Remix IDE, and you're going to use the Remix IDE to we'll be going to use our Remix IDE as our environment before we go onto VS Code. So we will be using Remix to simulate how a blockchain will look like when coded. So the first thing you will delete all the files, all the folders that you will find in the website. Delete all the folders, and then you come using this icon here. You create a new folder and name it SRC, and then inside the folder, when you've selected the SRC folder, you create a new file called the file simplestorage.sol. So you have to remember that when using Solidity, you have to use this .sol extension. So the .sol extension just signifies that this is a Solidity file. So whenever you're creating any Solidity smart contract, you have to put the .sol there. So if it's a smart contract written in Solidity, you add .sol. So when you come inside the simple storage.sol, this is what you see. You will see it will be blank. This I have written this one, so it will be a blank slate. So what you'll do, you'll start with SPDX license identifier, and then specify the license, which is MIT. So remember, I last session I told you that these two lines are the most important lines when beginning a smart contract. You have the two lines. So the first line is the one specifying the license, and then the second line is the one specifying the compiler version of the Solidity, the compiler version that is being used to compile the Solidity language. So in our case, it is any compiler that's above 0.8.1. 0.8.13. So any compiler version above 0.8.13 can be used to compile our code that we will write. So the next line we will write contract. So we will declare that this is a contract, and it is called a simple storage contract. And then we will open up the curly brackets, and this is where we will input our content, our contract. This is where we will input our contract functionalities. Whatever we need the contract to do, this is where we will input them. So we need a simple contract. So these are these two lines are used to show comments. So whenever you want to put comments, comments are the non-executable lines of code in your code base. So they are not executed. So they're just there to guide you as a developer. You use them when you want to maybe understand more about a part of your code. So you use the comments. So in our case, we just write a comment to show. So we are creating a simple smart contract that stores stores names, creating a smart just the names. So it's a simple smart contract that enables users to store their name. The smart contract also enables users to retrieve their oh sorry, so the contract stores their names and their registration numbers. And then the contract also enables users to retrieve their names and reg numbers from the blockchain. Remember, since the course is blockchain oriented, the smart contract, the simple storage smart contract is basically a smart contract that enables a user to store the name and registration number in the blockchain and retrieve the same from the blockchain. So we will start by the first. We'll start with the first. So remember last week we started by defining the solidity data types, and we talked about boolean, we talked about the integers, where we talked about uint 256, which is the unsigned integer. We said that unsigned integer is only a whole number, and signed integer can be a negative and a positive number. We talked about the address type. We talked about bytes. Bytes. We said that 1 byte equates to 8 bits. Yeah, we talked about all those, and you need to also understand about check the Solidity docs to understand more about Solidity and how it works. So, we will start writing our simple smart contract. So, we need our smart contract to store our favorite number, or sorry, our registration number. And when storing our registration numbers, I want us to assume that the registration numbers that we have are not like the ones that we're using in school that are both hexadecimal. I want us to that are both alphabets and numbers. I want us to assume that our registration numbers are just purely numbers, and let's go with that. So we will start. We start with our first function, which is to our first function will be store. Since no, but before we write the functions, we need to actually uh, we need to define what we're storing. So we start by, so this is called variable definition. Uh, this is where we give what are variables. First of all, variables are placeholders for different values, and a variable can be a data type. Remember we talked about data types. So in this case, uint, we say uint 256, that can actually be a variable. Uint 256 is a variable, and we say uint 256 registration. So that is what we will be storing. That is a variable. So remember, uh, we have to input the variable, so that when we have to, how can I say this? We have to declare the variable, so that even when we are writing a function that down here, the compiler will recognize that this function has been the variable that we are calling has been declared. So when writing this Unity 56 here, this is called initialization. So it's basically initializing the variable registration number, so that when we come and use it down here, uh, it will not, the compiler will not question where it is from. So since we want a smart contract that enables us to store our registration numbers, we will first start by writing the function store. So the smart contract will be able to store our uint 56. That is the variable that it is taking. It is storing our registration number. So the reason we are using underscore here is because, so first of all, I'll explain function. Function, this is just an inbuilt function, an inbuilt keyword that is used to show a function. That's basic. And then store, this is the custom name of the function. So whichever you want, whatever you want your function to do, that's what you call it. If you want a function to deposit, if you want a function to add funds, if you want a function to remove funds, if you want a function, you can call a function whatever you want to call it. So in our case, we are calling it the function store. And then we have this registration number. So the reason we use underscore here is because this function has to replace to update the variable up here. Remember, this variable, when you initialize this smart contract, there is a variable. You first of all store this variable registration number. So it cannot be the same, because for example, when you enter registration number, it will be different from this one. So we have to have different, there has to be a difference in naming, so that you don't confuse it with this variable, so that the compiler understands that, okay, this variable was declared, but now we've updated that variable to match the registration number that we've been given. So it cannot be the same. We just have a difference in naming, so that we can the compiler can understand better. So in short, we have to, okay, let's maybe put a comment here, so that it's understandable. So to put a comment, you can use the 2 lines, or you can also use this. You You can also use this for comments apart from the 2 lines. So here we will say that here the reg number is used as a store value. A store variable, sorry. So this one just stores the it simply stores the variable. So this one down here, the one with the underscore, this one is now the ones that instantiates the local variable. So it shows that okay, we need a registration number. This one shows that we need a registration number, and now this one is the actual registration number that you will input. So we can check if this one works. Oh, okay. First, we've not finished our function. So function, we have to have a few parameters. So first of all, we put it as public. So we have to understand that we have different visibilities. So we have public, private, and external and internal. But this ones we'll talk about them in our next class. So public, so the function store public, then let's say my registration number is equals to so that is because it has not been defined. So as you can see, this is what happens when you try to alter. For example, if you didn't save something, if you didn't initialize it here from the start, if you didn't store the variable, uh, the compiler won't understand what's going on. Where did this variable come from? You see it's saying undeclared identifier. So you have to store these variables if you need to use them in your functions. So any with Solidity, any variable that you have to use, you have to store it up here so that Solidity knows this variable. So in our case, we're supposed to just use registration number like that without the my. So when we deploy this, we're going to we can use this button here to compile it, and then you can come here. Okay, we need an environment. We need a custom. Okay, we can just use MetaMask, but I don't want to use MetaMask. I don't have enough gas fees in there. So let's the MetaMask is supposed to pop up. Why isn't it popping up? So we've already compiled the transaction. So I want us to deploy it on our test network. This is our test network. I don't know why it's not. It is supposed to. Let's use Brave instead. MetaMask is. Just a minute. I have to input my password. Okay, sorry. Oh, yep. No, very loud. No funds. Okay. Let's see whether it will deploy. Yeah, I hope it deployed. Okay. And then we have to confirm. So this is why the private key is also important, guys. It's the one that is used to confirm the transactions. So has it deployed? Yes. Okay. So we've deployed. Okay, have we? Wait. Hmm. So okay, deploy now. Oh, it's we're supposed to see the logs here. Creation of. Oh, why is it refusing to deploy? Okay, let's try using MetaMask. So you have to ensure that you connected your wallets well, so that it doesn't become a problem. Okay, let's try and use this account. I think it has enough. These are Sepolia F. These are actually test nets. They are not actual funds, so don't get excited. Just test nets. So let's try to deploy. It's supposed to give us. Okay. I don't know why. Okay, creation of simple storage pending. Pending. Wait. Okay, there it is. Come on. We use MetaMask. So you have to sign the transaction for it to deploy to the blockchain. You have to authorize that it's you who's deploying it, and you have to have some network fee, some gas fee. Yeah, I hope it goes through. It has. So I had some gas fees, luckily for me. You see, after the okay, it has failed. Come on. Okay, I don't have sufficient fees. We will see how we get test nets. Let's continue. We have to get test nets, and unfortunately, I don't have enough gas fees. But as you can see, this is the second transaction. As you can see in our terminal, we have here you can see all everything that you need. Uh, I think I'll try. I have some funds in. Come on, this is too little. To accessing the test nets is usually a bit tricky. Okay, I don't know why it just stopped. See, as you can see, when you deploy, so this is just trying to write to the blockchain. You see, that's where gas fees come in. In order for you to write to the blockchain, you have to have gas fees. Now you see, I think I have exhausted all my build test nets, so it's a bit tricky. And but you can see these are ABI code. This is these are the details. Okay, I am fed up. So what shall I do? I know what I shall do. Mm, let's try and use Brave and see whether or not Brave will work. Insufficient funds for gas, unfortunately. And this one is not even deploying to the test net, it's deploying to the main net. I don't want to deploy to the main net. I want to deploy to the test net. So you have to understand the difference between mainnet and testnet. Mainnet is like the main blockchain, like Ethereum now, or any other blockchain. But then testnet is just the ones. These are the ones that we use for development. And unfortunately, I don't have any testnets. But in case you need test nets, you can visit a few websites. There is, okay, let's see. But I tried getting test nets today, but I don't think I can get any more. So to get testnet, you can go to faucets.chainlink.chain. Don't link, yeah, that one. So Ethereum, Sepolia, and Sepolia, and this one, Sepolia ETH. So request for native reward is we don't have the one link. So let's try and this. Which account is this? Okay, acquiring testnets is a trick process. That's the problem. It's the like in web API keys can sometimes be a bit so that's the problem with Web3 acquiring acquiring testnets. Uh, okay. I think we should move on. Since that's not working, let's look at let's look at the visibility. Where are they? So when talking about visibility, we have to understand a few things about visibility. There are four examples, four mostly used visibilities, and for example, let us look at this code here. Come on, I'm looking for visibility. For example, if we look at our code here, we stated this, we labeled this function as public. So in visibility, we have four different. four different visibility functions. So these visibility specifiers include the public specifier. We also, okay, I can just write here. So we have the visibility specifiers, and we have four. The first one being public, which is known to most of you. So this means that the data inside the contract is accessible by this means that the contract can be accessible by the contract itself, can be accessible, let's use internally. So the contract is accessible internally, externally. It can also be called by the contract itself about the public visibility. You have to understand that it creates a getter function for storage. This means that other people can call this variable, meaning whenever a function has been labeled public, it is a getter function. For those who have coded, know about getter methods, and the other one is, no, we have the getter functions and the pure returns functions. So getter function, they enable us to get something from the function. What do I mean? For example, when in our function, the function store public. So this means that anybody can call the function. Anybody can store their registration number in this blockchain. So if the visibility specifier is public, this means that anyone can actually blockchain. So the contract is accessible both internally, and by internally I mean that can also be accessed by the contract that it is. So you see that it is in the contract simple storage. So a call this function can actually call it because it is a public function. So the second visibility is the contract is only accessible internally. So this means that only the contract itself can call the function. So if any other external contract tries to call the function, then it will not work. Only the contract itself can call the function. So if this was private, it means that nobody else can call this function apart from the contract itself. So it does not necessarily mean that it has hidden any value. It only restricts the access. So you can still see the value of the function and everything, but you cannot access it. You cannot call the function yourself. So for example, if the function store was private, it means that the function will only be accessible from within the contract. It means that any other contract, any other person Any other wallet that is trying to call the function cannot do that. So the other one is the internal. So this means that a contract is visible by the current contract only. So in the internal, this is the third. The internal visibility structure means that a contract can only be accessible by the current contract. So it is only visible by the current in the current contract. So it means that it cannot be seen by external contracts. Let us first of all explain the visibility external. So this we will be using the for a lot. So you need to understand uh, there are. So this one means that the contract is only visible externally to other contracts. So in Web3, when you're thinking about Web3, you have to understand that we have uh, contracts. So contracts are what execute the logic. They are basically the logic of Web3. So when we say a contract is only visible externally, it means that uh, yeah, a function. Sorry, remember these visibility specifiers are used by functions. So it means that a function can only be seen by other contracts externally. So the internal, the contract that the function is in, when you use, for example, you use this external here, it means that this function store is only to be seen by an external contract. It is not to be seen by this contract here. This function is not to be called by the contract here. So you will find examples where a function is in a contract, but that function it's external, so it's only supposed to be called by another function. It's not supposed to be. It's not being called by the function, the contract itself, but an external contract. And this is very common. This is a very common example, and it happens a lot. So these are the four visibility specifiers, and in case none is given, internal is the default, and yeah, internal is the default visibility specifier. And then public consumes the most gas fees, according to my knowledge. Public consumes a lot of gas fees, and yeah, since the public, remember we said the public visibility also acts as a getter function. uh, it gets things from the blockchain, or let's say that. So yeah, so let's write a function to. So this was just to highlight you on the visibility specifiers and all. Uh-huh. I don't want to delete them. So we've okay, though we've not executed our function, So what's supposed to happen was that when we deploy this to the blockchain, we will have a yellowish button like this here and a place where we can store our favorite number or our registration number. So for example, if your registration one, you can just store it registration one. And then, but since we haven't done that, we can just move on. I will get test nets, and by Saturday during our practical sessions, I will show you. So, function retrieve. We will continue with our next function. So our next function will be to retrieve our our what our registration number from the blockchain. So we want to save in such a way that we can store. So you have a place where you can store your blockchain. So the program allows you to store your favorite number, and then you can retrieve it by just viewing it. As in, you put your registration number in a ledger, and then you can only view the ledger, or you can retrieve it and view it. So that's what we will be doing here. So we will function retrieve. So we want to retrieve our registration number that we had stored. We want to retrieve it in such a way that when we press the we'll get buttons here. When we press the retrieve button, it returns our favorite number that we had stored. So we write public, and since we want to view it, we just want to view returns. We use the view keyword. View is a keyword, and returns is also a keyword. So we have to specify the parameter of the value being returned, which is uint 56, and then we open up the function and say return favorite number, sorry, registration number. So there you go. So you can compile. So I want us to talk about the view keyword. So we've compiled. Okay. Compile and run. Will it deploy? Let's try deploying again. I don't have any test net though. No, this is so disappointing. I don't have any test net. Yeah, test net ilifungua kweli. Okay, acha tuone ita take how long. It will come. So let's check our MetaMask. forget your password, the password to your MetaMask. Okay, still failed here. Mm, come on, guys. Oh, look at it. 0000. I only use MetaMask for testing, and actually there was another project I was working on today. I didn't finish it because I don't have test nets. I really need test nets. AP. Okay, which is this? Oh, looks like account 3 has some goodies, and account 4. No, it's account 3. Okay. Let's see. Let's try and use account 3. Account 3 tajiri. Okay, let's connect and see. West End. Which network is that? Okay, I don't know which network is that. Let's see. But I needed a test net. Hope it's a test net. The last time I was trying it out. Okay, it didn't go through. Come on, guys. This is so disappointing. But brave. Okay, so yeah, I remember the last time Meta Remix was giving out. They had accounts. You could just choose from an account. Accounts that were here. I don't know why they removed them. You could just this sucks. Anyway, uh, I think okay. Let me talk about the view. I'll talk about the view part. Okay, hii imekata kabisa. but I'll be sure to show you guys. So this is the terminal. This is where you check whether your deployment is working or not. As you can see, you may want to cautiously increase the gas limit if the transaction went out of gas. Okay, let's try and increase the gas limit. But MetaMask doesn't want to change to MetaMask. We'll do that later. So this is the terminal. Okay. So I want us to talk about the view and pure public keywords. So we have view and pure. So this is view. I have an idea. Let me use capital letter and pure keyword. So pure. So in our case, we used the view keyword. So let me just explain why we use the view. So view, this first of all, they are used to when you want to read the values from a blockchain without altering its state. So like I said, stored the function store. This function store is used to write on the blockchain, and then the value, these two keywords, view and pure keywords, are used to when you want to read a value from a blockchain without altering its state. So they don't initiate transactions, like they don't do transactions. They only make calls to the blockchain. So they ni kama messenger, like ye kazi yake ni kuita watu. For example, let's give it a school setting. So the person who goes to call the students, kuna mwenye anawa admit hapo, na kuna mwenye kazi yake ni kwenda ku pick out the students. So that's basically what the view and pure function does do. And the difference between them is that view, it just you allows you it just allows you to read the state, to read whatever you want to read from the blockchain. So whenever you see view, just know that you can't do anything. It's just viewing from the word. And then pure keyword, pure is used so pure prohibits against, disallows updating state of blockchain, and also reading. So whenever you see a word with the pure keyword, just know that function is not being allowed to read or update the state of the blockchain. So, and the keyword return basically specifies the type of value a function will return. So, return this basically specifies the type of what a function should return. So yeah, so for example here you see return registration number. So this is the type of value the function returns. So we expect that when we retrieve our registration number, we expect that the function will return to us our registration number. So these are all examples of keywords. These are all keywords that we have used here, and this is how we will be learning as we continue knowing projects, as we continue learning. And I think I will stop from there. I don't have much. I wish we had the time to do. I wish we I wish we deployed the contract. I wish I had test nets, but unfortunately, I don't have test nets. So I want us to do this on Saturday session, the physical session that we will have on Saturday. I really want us to do this. So yeah, I'll end the meeting at that. Since we don't have a quorum, I don't think there are any questions. But I am moving so fairly. I'm not moving fast. Bear with me. Yeah, and see you in